Okay guys, today we're going to do Unit 1, Section 3A, Solving Inequalities with Addition and Subtraction. So there's not a lot of new information here. There's just a little bit, and then we're going to do a little bit of practice. So here's a little bit of notes that you need to put in. The first one is less than or equal to, and remember that is important. Is less than or equal to. And then we have is greater than or equal to. Now when we're doing this in our algebra class, we're going to have to do a linear graph and a line graph. And when we do that, and if we see that there is a equal to, then we have to do a closed circle. Okay. Now, if we're looking at just a plain is greater than, notice the difference. There's no line underneath of it. Or is less than. Then we have an open circle. And that means our boundary is not included. Okay? So these are going to be important as we do our graphs. And that's what we're going to do today. Now I'm going to ask the same questions I asked when we were solving equations, but now we're going to be solving inequalities. So we're going to do a couple of examples. So let's start with our first example, and then you'll see where the open and closed circle come into play. So here's our first one. X plus 2 is less than 5. Now this is different than an equation. There's a lot of possibilities here. There's a lot of answers we could put in here to make the left side smaller than the right side. Speaking of sides, just because it's an inequality doesn't mean it doesn't have sides, but to indicate to myself that it's not an equation, I'm going to use a dotted line so I know which side is which. Okay, I'm going to go through the same questioning that I went through before. My first question is, what wants to be alone? And in this case, of course, in all cases, it's going to be the variable. And the variable that wants to be alone in this case is the x. So x wants to be alone. The next question is, what's crowding that variable? And what's the operation? And so we know in this case, the operation is plus 2. So we need to do the opposite. So we're going to take away 2 from both sides. Again, both sides, because we have to keep a balance. Otherwise, we've broken the rules of algebra. We'll get the wrong answer. So we're going to subtract 2 from both sides. Now, the answer we get is x is less than 5. Now I want you to stop and pause and think of a bunch of numbers that are less than 5. And all of those answers could work in this. So there's not just one answer. So some of the answers you could have said is x could equal 2, x could equal 3, x could equal 4. X could not equal 5 because we don't have the line underneath it. Because there's no line under the inequality, it cannot equal 5. X can be 4.999999999, but it can't equal 5. So we're going to represent this on a line. And just so you're not tricked when you're doing your tests and stuff, the line will already be there so you don't forget that you have to graph it. The first thing you want to put down is that number. And then you have to decide, is it an open or is it a closed circle? Well, since we're missing the equal on the bottom, that means it's going to be open circle. So we're going to put an open circle on the 5. And then what I want you to do is put the number right below 5, which is 4, and the number right above 5, which is 6. Well, which of these makes this true? Is 4 less than 5 or is 6 less than 5? And here's what I mean. I'm going to take this equation in my mind and I'm thinking, is 4 less than 5 or is 6 less than 5? I'm replacing the x with one of those numbers. I'm going to cross the one out that's not true, and then I'm going to draw an arrow towards the one that is true. And so that's how you finish this problem. You got to think of which way your arrow goes. So all the numbers less than 5, but up to but not including 5, could make this inequality true. Okay, The next one's really tricky. And the reason I made this next one this way is because I want you to see what happens when the x is on the opposite side of the inequality. There's this notion that an inequality symbol is an arrow, and that is not true. That is only true half of the time. So I don't want you to think that. If you were taught that, I want you to forget that. That's not true. All right, I'm first going to draw my line so I know which side is which. I'm going to ask myself the question, what needs to be alone? The x. What's crowding it? Plus 7. So I'm going to subtract 7 from both sides. Now again, if you're bad at negatives, just get your calculator out and check to see if you got the right answer. I don't want you to get the problem wrong just because you're trying to do math in your head and you just don't know it yet. So in this case, we have negative 5 minus 7, and so that's going to give us negative 12. Now what makes this problem even more difficult is that we're in the world of negatives. So we have negatives and the x is on the wrong side. I really recommend that you don't try to switch the x around, okay? Most people, when they switch the x to the other side, they get the inequality backwards. So I'm going to still put my negative 12, and now I need to decide open or closed circle. Well, to figure that out, I'm going to go back over here and I'm going to look at my inequality. That line tells me closed circle. Okay, so I'm going to put a closed circle at negative 12. Now I need to decide which way the arrow goes. Which one makes this true? Now in the world of negatives, you got to be careful. Negative 11 is actually bigger than negative 12, and negative 13 is smaller than negative 12. So again, in my mind, I'm going to rewrite this. Now whether you rewrite it for real or not, and I'm going to go negative 12, is that less than or equal to negative 13? Or is negative 11 less than or equal to negative 13? And you got to think really carefully, okay? The further left we are on a number line, the smaller we are. Okay, so, whoa, I did this one backwards. This one should be this way. Whoa, I messed up. Sorry. So this should be negative 12 is less than or equal to negative 11. Okay, so which one is true? Is negative 12 less than negative 13? Or is negative 12 less than negative 11? And this is the one that's true. So that's the way we point our arrow. Okay? And we cross out the one that's not true. Again, you can do this in your head or you can write it down. Now this can be really confusing to some people. So if that wasn't enough explanation and we're done the lesson today and you're still like, I'm not quite sure which way the arrows go, that's why you come in tomorrow during class and you ask somebody. You ask to be in the group that gets a little bit more explanation. Okay, so let's go to number 3. Number 3 is a little easier. We're going to do 2 more examples. X minus 9 is greater than negative 5. I want you to try this on your own. Pause the video, do it on your own, and then come back. Okay, so we draw our line if we need it. We're going to add 9 to both sides. Again, don't be ashamed to pick up your calculator. Depends on where your working memory is, depends on how tired you are. Negative 5 plus 9 is positive 4. Did you get that right? Okay, we're going to draw a number line. In the middle of our number line goes our boundary, which is 4. And then we're going to do the 2 numbers on either side of it. Now we have to decide open or closed circle. So we look at the less than or equal. There's no line under it, so that means open circle on the 4. And now we have to decide. This says that x is greater than 4. So we need a number that's bigger than 4. Well, is 3 bigger than 4 or is 5 bigger than 4? In this case, it's 5, so the arrow should go this way. And if you keep getting the arrow wrong, that's why you're going to ask tomorrow, because I'm explaining it the best way. I know how to explain it, but sometimes Miss Sally or Miss B or another student will explain it in a little bit different way that'll help you understand. So keep asking until you understand it. You just got to keep asking, okay? All right, let's try our last one. And this is a really tough one, so I'm going to write it, and then I want you to pause and see if you can get this one. Negative 8 is less than x minus negative 7. Now before you start it, those parentheses don't mean anything. They're just separating the negative from the subtraction. If you want a hint to start, you can pause and start it now. If you want a hint, you might want to change subtracting a negative is the same as adding. That's going to be the key here. Now pause it and try it. Okay, hopefully you paused and you already got your answer, so you're just checking your work. I'm going to subtract 7 from both sides of the inequality. And then it says negative 8 minus 7, that's negative 15. Don't forget this is an inequality, so don't forget your inequality. Sometimes I accidentally put an equal sign. And then we have our x. Okay, so on our number line, we put negative 15. And again, world of opposites, so be careful. Negative 14 is bigger than negative 15, and negative 16 is less than negative 15. Again, decide open or closed. So we look here, there's no line under it, so it's an open circle. So we put an open circle at negative 15, and now we have to decide. This says that negative 15 is less than a number. Well, if negative 15 is less than the number has to be bigger. In this case, it's negative 14. So it goes this way. And again, if that's a little confusing, that's understandable because we're dealing in negatives and the x is on the opposite side of the inequality. Please don't be afraid to ask if you're still not quite getting it tomorrow that you, ooh, I put that the wrong way, didn't I? Look at me, I'm not even thinking. No, that's right, x is greater than negative 14. I did it wrong in my notebook, see? You got to really be careful with these because we're in the world of negatives. So you got to make sure you do these correctly and carefully. So just in case you thought I was perfect, you'll learn throughout the year that I make a lot of mistakes too. I know the math, I understand the math, but if I get going too fast or if I get too sure of myself, I'm going to make a mistake. Okay, feel free to say, hey, I think you made a mistake. If I didn't make a mistake, you'll learn from that. If I did make a mistake, we'll all learn from that. So again, if you still need help with this tomorrow, make sure you ask. This is just a brief introduction. So if this isn't enough, that's okay. We're going to work on it again.